there everyone, this is Shivani Patel. I'm a certified application engineer with GoEngineer. In this video we're going to see how to monitor the stress due to escaping flow inside of a steady state analysis and flow simulation. In this example, what I've done is cut a small hole in one of the lids. Obviously you could cut that piece into any crack or opening in your model. This one's here to be simple. Now the act of cutting a hole in one of my lids does make this assembly not fully enclosed. Now if I don't have a fully enclosed part inside a flow simulation, I can't do an internal analysis. So now I'll be doing an external analysis, which means I'm going to have to define air on the outside of my model as well. Now for heat conduction, radiation, and so on, we won't need those. I'll have air flowing in, coming out of that hole, and going out into the air. Alright, now I need to decide what kind of fluids I'm going to be using. The first one I'm choosing is going to be the fluid filling the pipe initially. So I'll have it filled with methane. And air is going to be all on the outside of my system. You can see I've got both of those checked. I got to check my concentration. This is very important. If you leave both of those check boxes on default, you have to come over here and pick different mass fractions. So right now I have this as air is filling the entire system, and then I'll have methane come in on a boundary condition. Stick with my default mesh there. Now with my boundary condition, I have to put this on my inlet face and define this as the volume flow of methane. Since this is a steady state analysis, I didn't turn on transient. I'm not too concerned with the way the air is purging out of the system here. All I really care about is the stress in that hole. Last, this computational domain is defaulting to a couple sizes larger than the assembly. Since I'm only doing external just for that small region, I only really care about having a box that's a little bit higher than it needs to be. All these other dimensions are just wasting my calculation time. So go ahead, shrink that computational domain down, and then run your analysis. Now I've already completed one, as you guys saw before. The only other addition is some static pressures on some of the outlet faces. And you would get the results that we saw at the beginning of this video. Good. You can do a cut plane, choose a mass fraction type of any of the fluids you've chosen, and you'll get a very similar plot. Now we have to take this fluid information and take it into simulation, because simulation is where we can find stresses. You can't find stresses inside of flow. So you want to go to Tools, Flow Results, and export results to simulation. What this does is it takes the fluid conditions on each of the faces and remembers them for later. It also gives us the ability to come over here to our static study, go to Properties, the Flow Thermal Effects tab, and load in those results. Then you can go ahead and run your analysis and you will get your stress on your part. This has been Shivani Patel. I hope this video helped explain how to figure out the stress due to fluid pressures on a part and how to apply that for a gas leak scenario.